Good afternoon. So we have completed our unit number 5, that is numerical methods, and in that we have seen lastly 2-point and 3-point Gauss quadrature formula. So is there anything, any doubt in that? Any question in homework somewhere that you couldn't solve? You can ask if there is. Okay, there is one question, last one. Have you tried it? Just check the question. Let me just show you the last question. Can you read for me? Integration 0 to pi by 2 d theta upon under root 1 plus sine square theta. Have you solved it? By 2-point is asked. Have you solved this question?
No, ma'am, not yet.
Okay. What about others? Other questions? Have you solved other questions or not a single one? Okay, in this question, the problem is while you put this as f of theta, right? We have to write one as function that is 1 upon root 1 plus sine square theta. A is 0, B is pi by 2. 2-point we know. What is the formula? 2-point. I is equal to?
B minus A by 2.
Right. W1 f of theta 1 plus W2 f of theta 2 because we are in theta. Where, what is Z1, Z2?
Minus 1 by root.
W1, W2. Sorry. 1, I'm writing 1 and. Yes, W1 and W2 both are 1. Z1 is minus 1 by root 3. Z2 is 1 by root 3. Okay. And then we need a formula of theta 1. What is theta 1? B minus
A by 2.
Z1 plus
Z1 plus B plus A by 2.
Right. So B minus A, pi by 2 minus 0, pi by 2 by 2, pi by 4 into Z1 minus 1 by root 3 plus pi by 2 plus 0, pi by 4 by 2 by 4. Okay, solve this value and solve theta 2 also. What is theta 1? What is theta 1? Three 31948. Correct? Find theta 2 also.
0.5773.
Theta 2? Plus pi by 4 is remained. Add pi by 4. You're getting 1.238848. Check. Are you getting the same values?
Yes, ma'am.
Right.
Yes.
Okay, so we have them and we can then now put it in 1. So before that we'll need f of theta 1 and f of theta 2, right? So we'll find those values. Before that, this function you should write on your calculator. Try writing it. So for I is equal to b minus a pi by 2 minus 0 by 2 pi by 4. W1 is 1 into f of theta 1 plus W2 is 1 into f of theta 2. and theta 1 is 0.331948. So if you are done, press this on your calculator and solve for theta 1, that is this theta. What is your answer? Are you getting the answer? First, make sure you are in radian.
Error.
Error, right? You will get the error because sine thetas and sine x are okay, but whenever there is square while writing trigonometric square on calculator, you should always write sine theta bracket square for sine square theta, then you will get the answer. So instead theta you will go with x. So on calculator you will write 1 divided by bracket under root 1 plus sine x. Sine, to that side you should write bracket and its square. Okay, and one more bracket complete. Press this 1 by bracket under root, one more bracket. No, I haven't given. 1 plus sine alpha bracket. Before sine there should be the bracket. Sine we just delete the bracket complete its square and bracket complete. Calculate for 31948. Are you getting something?
No.
1. Yes, sir. Under root bracket 1 plus bracket sine x bracket complete square, one more bracket complete. Mismatched. Calculate for. Okay. This is also okay. And if you are giving bracket inside, that is also okay. Chalo. So now you have this on your calculator. Press calculate and calculate for this theta. 0.331948.
0.950786.
Correct. So you will get f of theta 1 as 0.950786. Now calculate for this value. Calculate for 1.238848.
0.726663.
Correct. 0.726663. Right. Add it and multiply by pi by 4. 0.950786 equal into pi by. What is the answer? Check. Is it 1.317465? Yes. So in your given answer, I have given 1.311028. So we are there. 311028 because we have ignored some values here. So that's why we are getting, but 1.31 we are getting. So yes, we are correct. So one more to note, while solving sine squares, do not write sine and its square. Write sine x first and bracket square. Then only you can solve on calculator. Is it clear now?
Yes.
Because while you go to solve, you will face the problem. That's why I'm telling you. Chalo. So I guess there is no other doubt in that. We'll go with unit number 6, Fourier transforms. Fourier transforms. So in that, the very first topic is Fourier integral theorem. Get the heading, Fourier integral theorem. Write in that, if f of x satisfies Dirichlet's conditions. Have you heard this word before?
Yes.
Yes. Where?
In
I
Fourier
think
series.
second chapter.
In Fourier series, correct. So for Fourier series also, function must satisfy the Dirichlet's condition, and for Fourier transforms also, function must satisfy those conditions. So do you remember the conditions? How many are there?
3.
3, right? In each finite interval, if f of x satisfies Dirichlet's condition in each finite interval, minus L to L, whatever, should be finite, it cannot be infinite. And if f of x is integrable, that function is integrable in that interval, or in the interval minus infinity to infinity, wherever it is integrable, then Fourier integral theorem states that. Okay, remember this. The statement of Fourier integral is 1 upon pi integration. These are the limits of omega from 0 to infinity. Double integration. Another is s from minus infinity to infinity. F of s into cos omega s minus x ds d omega. This is the definition of Fourier integral theorem. Fourier integral theorem. So f of s is something which we have as f of x, which is defined in this interval. So that x will replace by s, and we'll write it here. And accordingly, however is your function defined on the interval, the limits changed. So if it is defined in some, say, minus 2 to 2, so s will run over minus 2 to 2 for that function. And into multiplies to that is cos omega s minus x, or you can say cos omega s minus omega x. There are two variables, s and omega. Double integral. So this integration whose limits are minus infinity to infinity are the limits for s. So integrate with respect to s, and these are the limits of omega. So Fourier transform also transforms a function in time domain to the frequency domain. It also a transformer, acts as a transformer like Laplace transform, which changes time domain to frequency domain. Okay, so this is what the definition of Fourier integral transform is. So f of x is, let me write it again, 1 by pi. Omega is from 0 to infinity, s is from minus infinity to infinity. F of s into cos omega,
Cos omega.
right, cos omega s minus x ds d omega. But here we can see something, cos a minus b. What is the formula of cos a minus b? Cos a cos b,
Plus sin A sin B.
right, plus sin a sin b. So you can use it here. So therefore your f of x can be 1 upon pi. This is as it is. F of s into cos a minus b. A is omega s, b is omega x. So it is cos omega s into cos omega x plus sin omega s into sin omega x ds d omega. I just applied the formula there and expand it by using cos a minus b, sorry, sin omega s into sin omega x. Okay, now as there is plus in between, you can just multiply this with this with this, and you can separate the integration, right? So double integration gets separated. So to both of them, there is 1 by pi. So first part becomes f of s cos omega s cos omega x ds d omega plus f of s into this. So 1 upon pi to this again, integration 0 to infinity minus infinity to infinity f of s into this second term sine omega s sine omega x ds d omega, right? So now you have the function, they will give you the function, but if that function in the given interval, if that function f of s is say even, or you can say f of x, they will generally give you in x. Okay, if the f of x is even, means f of s is even, you are just changing the variable. So then f of s into cos omega s, what it will be, even or? Because this is even and cos is, how is cos function? Cos of minus theta is cos
Cos
theta,
even.
means cos is even function, and sine of minus theta is
Minus
Sine.
minus of sine theta, means how is sine function?
odd.
Odd
Odd.
function. And cos is even, and even into even is
Even.
even. So
Even.
this whole thing is even if function is even. And f of s into sine omega s, it will be, this is even, this is odd, sine is odd into even,
Odd.
Odd.
odd. So this is odd. And we know one more thing, integration minus a to a f of x dx. If your function f of x is even and if your function f of x is odd, there are two different values. So what will be the value if function is odd?
Odd for 0 and for even 2 integration 0 to a f of x dx.
Correct. 2 times 0 to a f of x dx. So whenever the whole function here is even, it becomes 2 times 0 to a, and if the function is odd, the integration for such where upper lower limits are same, just the changes in sign, the value is directly 0. So we'll check here. As we have considered the function is even, okay, so f of s into cos, okay, before that, because the integration here depends on omega, and this integration depends on s. So s is in this function, but not in this. So this integration depends on these two values. And here, this is the function of omega. So this integration depends particularly on omega. Though there is omega, but s is also there. So this is the function of s, and this is function of omega. So we can separate this. Let this in bracket. So therefore, f of x is equal to 1 upon pi integration 0 to infinity. From there, I can take out cos omega x, that is with respect to omega, because this is integration of omega. And then s is from minus infinity to infinity. There is f of s into the function of s only, right? I can separate. The same thing I can do with the second integral also, which is, yeah, sine omega x is the function of omega, so it will go here. And s function, these two are the function of s, so they will be inside. So it is integration omega from 0 to infinity sine omega x d omega, and integration minus infinity to infinity f of s into sine omega s ds. Okay. So next, if I'll consider now, your function is even, f of s is even, okay? So this is even into even, this part becomes even, and it will survive, it will become 2 times 0 to infinity. I'm not checking this, I'm checking this function into cos. And this part becomes even into odd, so what will be this value? Integration. If this is odd,
0.
and integration of odd is directly 0. So this value is 0 and whole part is 0. So the only thing remained is this, and with 2 times 0 to infinity to this integration. But when your function is even, correct. So here I'm going to define Fourier cosine integral. Do you remember now Fourier cosine series? Series. I'm asking you series, but I'm writing integral. Do you remember Fourier cosine series? Cosine कधी मिळालेला आपल्याला? Okay, when your function is even, what was 0 there? A naught, Bn was 0. So only the part remained was A naught and An. And An always comes with cos. Right? So whenever your function is even, we got Fourier cosine series. Do you remember that?
Yes.
Right. So the same thing is followed here. Whenever your function is even, you will get the Fourier cosine integral. So let me just define if f of x is even function, the thing which I defined last, then f of s is even, right? F of s into cos omega s is also even into even. And f of s into sine omega s is what? Odd. And I told you this is odd, so integration minus a to a of odd is 0. So this whole part is 0. This is even, so it is 2 times 0 to infinity. So 0 to infinity I'm writing, and I'm writing 2 times here. So your formula becomes 2 by pi integration omega from 0 to infinity cos omega x d omega, and this integration also becomes 0 to infinity, 2 times 0 to infinity, f of s into cos omega s ds. And this is what we call Fourier cosine integral, and we get this whenever your function is even. Do you get the formula?
Yes.
So as its name indicate, can you just see everywhere is cos only, no sine part is there?
Yes.
Cos, right? So that's why it is called cosine integral, and we got this whenever your function is even function. So yes, this we can write as equation number 1, and we are substituting this in 1. So 1 becomes now we have to define Fourier sine integral. So what should be your function then? Odd. Correct. You there in Fourier sine integral. And we get it when your function is odd. So define if f of x is odd function. That is f of s is odd. F of s into cos. What it will be? So this is odd. Cos is even, odd into even, odd. So yes, it is odd. And f of s into sine omega s, it will be
Even.
right. This is odd. Sine is also odd. Odd into odd is even. This is even. So we are now substituting it in equation number 1. Here we have seen that this is even. So even becomes 2 times 0 to infinity. 2 will come here, 0 will come here. And this is odd. The integration of odd is 0. So 0 into anything, this part is totally 0. So remainder is this one. That is f of x is equal to 2 by pi. Omega is from 0 to infinity. Sine, right? Sine omega x d omega integration s is from 0 to infinity. Originally minus infinity to infinity, but whenever even or 2 times, here it is 2 times 0 to infinity. F of s into sine omega s ds, and this is Fourier sine integral. So we have seen three definitions here: Fourier integral, Fourier cosine integral, and Fourier sine integral. We just collect them together and we'll go to solve the question. So first, Fourier integral. Tell me the formula. F of x is
1 upon pi.
right.
Integration omega is equal to 0 to infinity.
Infinity.
Is equal to infinity to infinity.
Right.
F of s into cos omega under bracket s minus x ds into d omega.
Correct. And this is Fourier integral theorem. Second, Fourier cosine.
2 upon pi.
Fourier cosine integral. You should collect this. The story is immaterial, but the formula are very important. They can ask you in exam. 2 upon pi.
Integration omega equal to 0 raised to infinity.
Correct.
Oh, cos omega x d omega. Integration
Integration
is equal to 0 to infinity.
f
F
of
of s cos
s
omega x ds.
cos omega s ds. Very good.
And for sine integral, change only cos instead of sin.
And for sine, we change all the cos by sine. Your sine integral. Do that. Just check. Am I writing it correctly? F of s into sine omega s ds. Note them. Sure, we'll go to the question. Write the question. Express the function. And remember one more thing. Though it is double integration, we never solve the double integration. We just will solve only one, and there will be one show that to show there one integration. The omega always remain there. We are just solving the part integration s to infinity. We'll solve the integration with respect to s only. You'll see in question. Just see that. Solve. Express the function f of x is equal to sine x in 0 to pi, 0 when x is equal to pi, and 0 again when x is greater than pi. Express this function as Fourier integral, and hence deduce that integration 0 to infinity cos omega pi by 2 upon 1 minus omega square d omega is pi by 2. So which part is not solved? The omega part. So these must be the limits of, with respect to omega it is. So these are the limits of omega. So omega part is not solved. It is there as it is. Only the s part is solved in the Fourier integral, and from that you have to show this. Okay, so now read the question properly. Express the function as Fourier. But what? We have seen Fourier series, we have seen Fourier integral, we'll see Fourier transform, then we have already seen Fourier cosine, Fourier sine series, Fourier cosine sine integral, and transform also. So you should read it very properly, whether it is Fourier series or integral or transform. Okay, so it is Fourier integral. Also read whether there is cosine, sine or something. So it's very important now. Whenever Fourier word come, it is whether it is series or integral or transform. So here it is integral, right? So we should now write the formula. So we know the Fourier. Any doubt?
No.
Okay.
No.
So Fourier
No.
integral. Okay. So Fourier integral formula is, write that formula. F of x is equal to, do not forget to write f of x. F of x is 1 upon pi omega 0 to infinity s minus infinity to infinity.
F
F
of
of
S
s, right? Cos
cos
Omega.
omega, right?
S minus X ds dw.
Correct. So now you have to write the function. Function depends on s, right? So your integration limits will change as your function changes. So you will now check the function. But they have given you f of x, but you have to write it as f of s. Okay. So your function is sine s in 0 to pi, but we have to see whether it is defined from minus infinity to infinity. Whenever it is in 0 to pi, it is defined sin x. Whenever value is pi, function is 0. Greater than pi, 0. Greater than pi means pi to infinity. The pi to infinity 0 at pi is also 0. 0 to pi value is defined. And when it is less than pi, the value is not given. Not given means? Not given means? We are checking minus infinity to infinity now. So pi to infinity, the value is 0. At pi, value is 0. From 0 to pi, value is defined. So when x is less than pi, pi च्या मागे means minus infinity to pi, what will be the value of the function? It is not given here. Not given means 0. I told you. The function जे दिलंच नाहीये त्याचा विचार नका करू. So ते 0 झालं. म्हणजे तुमचं function defined where it is defined only on this interval 0 to pi. So f of s is sin s in 0 to pi. So I'm writing here sin s and s limits are 0 to pi. So this becomes 0 to infinity as it is. S limits are 0 to pi, where function is sin s into cos omega s minus x ds d omega. Is this step clear?
Yes.
Yes.
Right. Now we have to solve this. So I'll just write cos omega s minus, I'll multiply by that omega inside. Omega s minus omega x. But now we know we cannot separate the integration in multiplication. So what formula are you going to use here?
2 sin A cos B.
Right. So here you need 2. So multiply by 2 and divide by 2. And now tell me the formula 2 sin A cos.
Sin of a plus b plus sin of a minus b.
Plus sin A minus B.
Correct. Sin A plus B plus sin A minus B. Apply it here. So it is 1 upon 2 pi integration 0 to pi s 2 sin A cos B sin A plus B s plus omega s plus minus minus omega x plus sin A minus B s minus omega s minus minus plus omega x ds d omega. But the integration here is with respect to s. These are the limits of s, means integration is with respect to s, right? So we should collect the term of s together. What are the terms of x? S, not x, s. Sin
Sin S.
s plus, here is also one more. So sin 1 plus omega s and remaining is as it is omega x. We are just collecting s plus sine. There it is 1 minus omega s plus omega x as it is. ds d omega. Now can we integrate? There is addition and integration of sine we are taking with respect to s. So it is integration of sine. Minus cos of this angle, whatever is the angle, right? Upon derivative of this with respect to s. What is the derivative? Derivative of this.
1 plus omega.
1 plus
1
omega.
plus omega. Correct. So I'm now taking the integration. So outer integration as it is 1 upon 2 pi omega 0 to infinity. And you told me the integration is minus cos. So what is inside? 1 plus omega s. Check once. Minus omega x. So integration of sine, I have written minus of cos upon 1 plus omega. Same here, integration of this sine is minus cos of this minus cos of 1 minus omega s plus omega x. Check once correctly later.
Yes. Upon 1 minus
Upon 1 minus omega. Very good. And these are limits. So this is the integration, but limits are given. Limits are
0 to pi.
0 to pi. So you are writing here from 0 to pi. S is over omega d omega. Correct. Okay. So now upper lower limits. कशाच्या जागी upper lower limits?
Yes.
S च्या जागी. Very good. So 1 upon 2 pi. This is as it is. 0 to infinity. Upper limit you are writing pi. So minus cos 1 plus omega pi minus omega x upon 1 plus omega minus cos 1 minus omega pi plus omega x upon 1 minus omega. Upper limit is done. Minus lower limit at s you are writing 0. So it is minus cos 0 minus omega x upon 1 plus omega minus cos 0 plus omega x upon 1 minus omega. Okay, done upper lower limits and then complete this with respect to omega. Okay, now this term, I'll just explain here and write it directly. So cos of this term is nothing but 1 plus omega pi minus omega x. So it is cos of pi plus omega pi minus omega x. And please remember we have one formula cos of pi plus theta or cos of pi minus theta, whatever it is always minus of cos theta. So cos of pi plus this theta, what will be the answer? Pi plus theta, this is your theta. Cos of pi plus theta is minus cos theta. So this is minus cos
Minus omega x.
omega pi minus omega x. Correct. We'll need this also. So let me just write that. Cos 1 minus omega pi plus omega x. Cos of multiplying inside pi minus omega pi plus omega x. Cos of pi, the omega x इकडे लिहिला असता तरी चालला असता. तर मग असं करा. मायनस ब्रॅकेट द्या पुन्हा एकदा हा मायनस होईल. ठीक आहे. So cos of pi minus theta, what it will be?
Minus cos omega pi minus
Cos
omega.
omega pi minus omega x. So this term I'm going to write like this. Therefore, it is equal to f of x is equal to 1 upon 2 pi integration 0 to infinity. This is minus of cos omega pi minus omega x. Minus is already there. So minus minus become plus.
Plus.
Cos omega pi minus omega x. Cos omega pi minus omega x upon 1
plus omega.
plus omega. Then for this, you are going to write minus of cos. Minus is already there, so it is plus cos omega pi minus omega x.
Yes.
Cos omega pi minus omega x upon 1 minus omega. Okay, then minus minus plus. But what is cos of minus theta?
Cos theta.
Cos theta. So this is cos omega x minus minus plus. So plus cos omega x upon 1 plus omega.
Minus cos omega x upon 1 minus omega.
But there is again minus outside. So minus minus plus
Plus.
cos omega x plus cos omega x upon 1 minus omega. This much is the part in. Okay, so now if you can see, these two are same. Their coefficient get added. 1 upon 2 pi, 0 to infinity is 1 upon 1 plus omega plus 1 upon 1 minus omega into cos omega pi minus omega x. Common thing is getting out. Same here. Cos omega x will take out. So 1 upon 1 plus omega plus 1 upon 1 minus omega into cos omega x. Common. Outside is d omega. But now again, if you can check, this bracket is common. So it is 1 upon 1 plus omega plus 1 upon 1 minus omega, common bracket, into these two get added. Cos omega pi minus omega x plus cos omega x d omega. Now you need to solve this. So it is 1 upon 2 pi integration 0 to infinity. Just cross multiply this. 1 minus omega plus 1 plus omega upon 1 minus omega into 1 plus omega into this cos. This is as it is. Okay, here minus omega plus omega cancel. 1 plus 1 is 2. This is a minus b into a plus b. What is that?
1 minus omega bracket square.
Correct. No, not bracket square. A minus b, a plus b, a square minus b square. So 1 square minus omega square. 1 minus omega square. So therefore, f of x is equal to 1 upon. Hello?
Yes.
Am I audible?
Yes, ma'am.
Yes, ma'am.
Yes.
Okay. 1 upon 2 pi. Integration 0 to infinity. What is that? 2 upon 1 plus 1, 2 upon 1 minus omega square into the part as it is cos. What is there? Omega pi minus omega x. Omega pi minus omega x plus
Cos of
cos
x
omega x, yes. D omega.
omega.
2 also get cancelled. And it is. Okay, can you just check your show that now? Show that is 1 upon 1 minus omega square. Yes, it is there. 0 to infinity. Yes, it is there. But numerator is cos omega pi by 2. But our numerator is something different. So we should get omega pi by 2. There is no x. So we should substitute something for that x. So what should we? So that we'll get omega pi by 2. What should we put for that x? So for this whole term, we want this. Think and tell me what should be x.
Pi by 2.
Okay, can you just check for that? Pi by 2. Omega pi minus omega pi by 2. pi minus pi by 2. Pi minus pi by 2 is pi by 2.
Pi by 2.
So it is omega pi by 2. And if you say here it is pi by 2, so it is cos omega pi by 2. So they can just get add together. So we'll get 2 times cos. We'll think about that too, right? Yes, we are getting this term if your x is pi by 2. So put x is pi by 2 there. So on both sides. This also f of pi by 2 is integration cos omega pi minus omega pi by 2 plus cos omega pi by 2 upon 1 minus omega square d omega. Okay, so it is cos omega, you know that this is omega pi by 2 plus cos omega pi by 2. 1 upon pi, like that. So yes, it becomes cos omega pi by 2 plus cos, that is 2 times cos omega pi by 2 upon 1 minus omega square d omega. This 2 can come out of the integration, as your show that does not have 2 here, so 2 comes here. So this is your show that. So this pi by 2 I shift here. So yes, we get pi by 2 into f of pi by 2 is this integral. Right? But now if we get the value of f of pi by 2, your answer will be done. So we should have f of pi by 2. But f of pi by 2 is, what will be f of pi by 2? You need this value of the function at x is pi by 2. So where pi by 2 comes in among these 3 intervals, where x is pi by 2 is
0 to pi.
right. In 0 to pi, somewhere there is pi by 2 in between. So the value of the function is sin x corresponding. So you are solving this for pi by 2, means you are solving sin pi by 2. What is sin pi by 2?
1.
What is the f of pi by 2?
1.
1.
1.
But yes, f of pi by 2 is 1. So writing that, you will get pi by 2 is equal to integration 0 to infinity cos omega pi by 2 upon 1 minus omega square d omega. That was the show that, hence the deduction. And just now check how lucky you are, because this is the compulsory question in theory exam. And if you'll be remain back राहिला तर तुम्हाला हा थेअरीला सॉल्व्ह करावा लागेल नेक्स्ट टाइम. तर मग ठरवा की आपल्याला हे थेअरीला सॉल्व्ह करायचंय की ऑनलाईन मध्ये पास व्हायचंय. इझी आहे, जस्ट यू नीड अ फोकस, कारण एखादं साइन जरी चुकलं की मग सॉल्व्ह नाही होणार. But have you noticed that you are only solving only the single integration, not double integration? The single integration, this part omega is always stayed back. It is always there, and you are showing that integration is. So only the part you are solving is integration s to, that depends on s. Omega is there itself. Is there any doubt, any question?
No, ma'am.
No.
So can I give you one homework? Will you try? Just try.
Yes.
Try it roughly. We'll solve it in next lecture. So find the Fourier integral of, find the Fourier integral of, and Fourier integral is only the biggest part, or the hard, we can say harder part in this unit. Whenever transform starts, it will get easier. Transforms are easier. So only this part is there. And hence evaluate is also there. I write here, and hence evaluate. integration 0 to infinity x cos x minus sin x upon x cube into cos x by 2 dx, dx. And one more thing, there is no x in your integration. You have seen integration is with d omega ds, omega and s, and we always solve for s. We retain omega back, so this is actually the omega finally they have replaced by x, so these x are nothing but omega. Okay, changing the variable is only the last step, so do not get confused. These x are actually omegas. Try them, solve it. Sure, no doubts, please wait, let me take attendance, then we'll stop. Do you have something to ask in between? You can go ahead and ask. So what is important here is the formula. They can ask you direct formula for MCQ. So what is Fourier integral theorem? What is cosine integral, sine integral? When will be IEC2? IEC2 is yet not finalized. Whenever the syllabus over, it will start. Because for IEC2, the remaining all is there. Unit 4 to 6, all the units should get covered, then only IEC2 will happen. No? Chalo, I'm done. Is there any other doubt you want to ask?
No.
Okay, chalo, we'll stop. Bye.